Okay, so the interval that we're given is a positive, the integrand's positive in the interval from 2 to infinity. So I can use a comparison test. Again, what we're saying is from 2 out to infinity, that, this curve looks sort of like this over here, and there's a finite area there. And what we're trying to do is we're trying to show that, whatever that area is, we can find integrals below here, and we certainly want them to be positive. We need the integrand to be positive. So kind of looking at it, just one at a time, certainly the first one I see is good. The second one is also good, it's a positive term, by the way. And they look all like they're positive term, all right? I mean, the integrand's all positive on the interval, the interval from 2 to infinity. But I'm looking for one that's smaller, all right? What do I mean by that? We're looking for one where the integrand would actually be smaller on the interval from 2 to infinity. And I'm looking at this thing over here, and I'm starting to realize only A is going to be smaller. Let me write this down for you. I am claiming on 2 to infinity that the integrand here let me point out what I mean by that. The integrand here, let me get my eraser out, this is 2 to infinity, is smaller than the other integrand. What's the other integrand? This one over here. By the way, I only have to show this for 2 to infinity. That's true, by the way, all right? Why do I know that? Everything's a positive number here, so really what I'm saying, x squared is greater than x, and that's true for 2 to infinity. If I look at the other ones, though, and not that I have to do that, what is this one saying? X is less than or equal to, x squared less than or equal to 1. And that's certainly not true to infinity. So you throw that one out. Look at the next one. What's that one going to be? 1 over the root of x squared minus 1. Compare it. What do you get over there? X is less than or equal to 1. That's not true from 2 to infinity. This one gets thrown out. Again, we're throwing things out, by the way. And last but not least, you're looking at 1 over, let's put this one down for you. A little more complicated, isn't it? All right, let's just, manipulate it. You get x squared minus 1, x squared plus 1. I guess that's square both sides, right? You get x squared minus 1, x squared plus 1. What do you get there? x4 minus x squared plus 1. So you get x4, and then you get x squared, 2x squared plus 1. And by the way, this is not true either. And looking at that, x4 is going to overpower x squared plus 2x squared plus 1 at some position, right? So I'm going to claim over here, this is the only one, whoops, sorry about that. This is the only one that makes sense over here. And this is what should be selected, is letter A. All right, let me get my highlighter out. Let's make sure that's been selected for you. It has, and we're good to go on to the next question. Thank you.